Hey everybody, welcome to video 5 on conversion factors. Conversion factors are a powerful tool we'll be using all year and you'll use in all your science courses. So let's get to it. So conversion factors, like it says here, expresses the relationship that exists between two things. So when we use conversion factors, whenever we want to change something to a different version or a different form. For example, changing units is a very common use for conversion factors. If you're in a foreign country and it's 50 kilometers to the next town and you want to know how many miles that is, you could use a conversion factor from kilometers to miles to help you figure that out. But it's not just for changing units. For example, take a look at this one. Let's say somebody gave me 5 guitars, but none of them have strings. I know that there's 6 strings per guitar, so how many strings am I going to need to buy for all 5 guitars? Well, I can use a conversion factor that expresses the relationship between guitar and strings to help me figure it out. So one way to think about it is one guitar has 6 strings and flipping it doesn't really change anything, but when I use it in a problem, it does make a difference which one of these I use. So to work the problem down here, if I have 5 guitars, I want to use the conversion factor here that has guitar in the denominator so that it will cancel and we'll be left with strings in the numerator. So 5 times 6 is 30 strings. I think you can see how things would have gone wrong if we had used this relationship here instead. It would have been 5 divided by 6 and we would have used less than 1 string, which makes no sense at all. So 2 things need to happen when we create a conversion factor. The first thing is it has to be true. For example, in the previous problem, let's say that we had made a mistake, we weren't thinking, and we said 1 string is equal to 6 guitars. Now obviously that's not the correct relationship, so we have to be careful when we write these conversion factors. The other thing is it has to be accurate. What if we said 1 guitar has 7 strings? Here, we won't get the right answer because 7 is the incorrect number here. So conversion factors have to be true and they have to be accurate. They have to express the correct relationship between the 2 things we're comparing. So here's a question that's not so straightforward. The previous one you probably could have done in your head, but not this one. How many seconds are there in the month of May? So to answer this, let's come up with some conversion factors. For example, I know there's 30 days in May, I know there are 24 hours in a day, and I know there's 60 minutes in an hour and 60 seconds in a minute. So how am I going to string these together to find out the number of seconds? So here's one way that it could be set up. Notice that all these conversion factors that we came up with, we used down here, but some of them were flipped so that the units would work out. For example, now days cancels with days, hours with hours, minutes with minutes, and we're left with seconds in the numerator, which is what we want to end up with. So when we multiply 30 by 24 by 60 by 60, we get 2,592,000 seconds for our answer. So here's another conversion problem. We're converting units. During the Olympics, I was watching the 10,000 meters, and I was wondering how many miles that was. So I found out that 1 mile is equal to 1,609 meters, so that's going to be my conversion factor. So I'm going to start out with 10,000 meters, and I can see that I want to use this conversion factor as it's written because meters are in the denominator and 1 mile up top. And then we do the math. So as you can probably see, this is basically a division problem. 10,000 times 1 and then divided by 1,609, and I've got 6.21504 miles. The problem here are significant digits. Look at the numbers we used to get that answer. This one only has 1 sig dig. This one has 4 sig digs. And so our answer here needs to be rounded to 1 sig dig, so really we should the answer should just be expressed as 6 miles. So take a look at these 4 different conversion factors. A kilometer is 1,000 meters. That makes sense. Kilo means 1,000, 10 to the third. So a kilometer has to be 1,000 meters. We could express it like this, or we could flip it if we wanted to, or we could express it like this, and it's also correct. If there are 1,000 meters in a kilometer, then it stands to reason that a meter is 1,000th of a kilometer. And you can see that both of these conversion factors that have kilometers in the bottom will give you the same answer. Multiplying by 10 to the third will give us the same result as dividing by 10 to the negative third. We look at the second example, 100 centimeters is 100th of a meter. We could express it like this, or we could simply say 100 centimeters is 1 meter. These two conversion factors mean the same thing. Likewise, down here, a milligram is 1,000th of a gram. In other words, 1,000 milligrams would make up 1 gram. And then down here, 1 nanoliter is 10 to the negative 9th liters, or we could simply say that there are 1 trillion nanoliters in 1 liter. Sorry, that's a billion. Okay, let's convert these two. 23.7 kilometers, always start with what you're given. Put the units in first, make a conversion factor. We're going to put kilometers on the bottom, meters up top, and then we're going to make this conversion factor true. 1 kilometer is 1,000 meters. So 23.7 times 10 to the third meters. Kilometers cancel. Now that's not in correct scientific notation. 2.37 times 10 to the fourth meters would be the correct way to say that. Take a look at this one here. We have 8.12 times 10 to the negative third centigrams. We need to convert those to grams. Put centigrams in the denominator, grams in the numerator. 1 centigram is 100th of a gram. When we multiply powers of 10, we add them. So the answer is 8.12 times 10 to the negative fifth grams. As you can see, the centigrams will cancel. Now, what if we're converting units that both have a prefix? I don't know if you noticed, but on the previous one that wasn't the case. But here we got to convert milliliters to hectoliters. So we have 83.5 milliliters. I'll put milliliters in the denominator, hectoliters in the numerator. But now I have to figure out what the conversion factor is. Now up here I wrote that milli means 10 to the negative 3 and hecto means 10 squared. These differ by a factor of 10 to the fifth. And so 10 to the fifth then will go, well, will it go in the numerator or denominator? Well, it's going to go by the smaller unit, milli, 10 to the fifth, and then 1 up there. And then when we divide, we get 83.5 times 10 to the negative fifth hectoliters. Milliliters cancel. With scientific notation, we have to move the decimal to the left 1 space. And so that's going to make it negative 4 hectoliters. Try this one. So in the second one, I already have it set up. Picograms in the denominator. I know that mega means 10 to the 6 and pico means 10 to the negative 9. They differ by a factor of 10 to the 15. The 10 to the 15 goes by the pico since that's a lot smaller than mega. And so 4.014 times 10 to the fifth is going to be divided. And when you divide powers of 10, you subtract. And so that's going to give us 4.014 times 10 to the 5 minus 15 is negative 10 megagrams. Here's a very straightforward dimensional analysis problem. Dimensional analysis is when we have to do several conversions and come up with several conversion factors. So in this problem, we've got a spool of copper wire that has this mass and it's this long, and we can see that per case there are 24 spools. So I came up with all these conversion factors from the information in this problem. See if you can pick those out too before we do the first question. Okay, so this is what I came up with. I got 5 cases, and so I need those to cancel, and there are 24 spools per case. And since we need mass, I knew that one spool weighed 352 grams, so I set it up so spools would cancel. But they don't want the answer in grams, they want it in kilograms, so that means I had to use this conversion factor. Grams cancel, and we're left with kilograms, and I got 42.24 kilograms. There is one issue, though, to consider here, and that's significant digits. For example, the 5 cases, will that affect our sig digs? No, that's an exact number. Okay, we didn't use a measuring device to figure that out. It's not an estimation. Nor is the number of spools per case. I mean, you can clearly count them, 1, 2, 3, so no measurement involved. But this, somebody had to measure that, and that 352 grams has 3 sig digs. The 1,000 right here is a definition. Kilo means 1,000 by definition. So what this means is this answer needs to be rounded to 3 sig digs, 42.2 kilograms. See if you can figure out this one. So here I've set it up starting out similarly to the one before. Cases cancel, spools cancel. We want the length in kilometers, so the meters have to cancel, and we end up with 19.608. Thinking about significant digits, this is going to be the only thing that affects it, and that has 4, so this answer should be expressed as 19.61 kilometers. We'll be doing a lot of English to metric conversion, so it's important that you have a conversion from English to metric for mass, for length, and for volume. Here's one that I use all the time to go back and forth from English to metric. Mass is kilograms to pounds, but this one works well too. For length, an inch is 2.54 centimeters. 1 meter is 39.37 inches is just as valid. A liter is 1.057 quarts. Well, a liter is 0.264 gallons too, so either one of those can work. The important thing is that you have at least one for mass, length, and volume that you know will work to get back and forth between units. So here's a problem where we have to convert 578 milliliters to quarts. Well, we don't have a milliliter to quart conversion. This is the only one that we have. That's okay. We can make it work. We can convert 578 milliliters to liters like this, and then a liter is 1.057 quarts, and that gives us an answer of 0.610946 quarts. But that number has 3 sig digs. This one doesn't count because that's by definition, but this English to metric conversion, we have to pay attention to the fact that that has 4 sig digs. Somebody rounded that off. So this number needs to be rounded to 3. 0.611 quarts then would be the answer. Here's a couple more in case you're curious about what your weight would be in the metric system. So what is your weight in kilograms? So here's one possible way, depending on what you weigh. And what's your height in centimeters? If you know what your height is in inches, then it's pretty easy. Thanks for watching.